Yes, telephone, data, television, and CCTV cable can be run in the same conduit according to the National Electrical Code. Section 800.44 A4 of the National Electrical Code addresses the installation of communications cables and specifically states that these types of cables can be installed in the same raceway, also known as a conduit, if the cables are listed for the application. This means that the cables must be certified by a recognized testing laboratory, such as Underwriters Laboratories, to ensure they meet the safety and performance standards for combined installation. Section 800.50 covers the requirements for the conduit itself. It specifies that conduits must be of sufficient size to accommodate all cables installed within them. Additionally, it mandates maintaining a minimum 6-inch bending radius for data cables to prevent damage and ensure optimal performance. There are several important considerations to keep in mind when running these types of cables together. Firstly, interference is a potential concern. It is advisable to avoid running high-voltage cables such as telephone or power cables alongside low-voltage cables such as data, television, or CCTV cables. This helps to minimize the risk of electrical interference, which can degrade the performance of the low-voltage cables. Secondly, grounding is crucial for safety and performance. Ensure proper grounding of all cables in accordance with National Electrical Code requirements. Proper grounding helps to prevent electrical shocks and reduces the risk of electromagnetic interference. Thirdly, cable types matter. Verify that the cables used are specifically listed for being installed together in the same conduit. This ensures that the cables are compatible and meet the necessary safety standards. While it is permissible to run these cables together under the National Electrical Code, there are some recommended practices to consider for optimal performance and reliability. Firstly, it is often recommended to install a separate conduit for CCTV cables. This is due to their high data rates and potential for interference. A dedicated conduit can help to isolate the CCTV cables and minimize the risk of signal degradation. Secondly, use a rigid conduit or heavy-duty flexible conduit to protect the cables from damage. These types of conduits provide better protection against physical damage, such as crushing or impact, which can compromise the integrity of the cables. Thirdly, consider using a conduit spacer or cable divider to separate different types of cables within a conduit. This can help to further minimize interference and prevent the cables from becoming tangled or damaged. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is developed and maintained by the National Fire Protection Association, or NFPA, and is widely adopted by state and local jurisdictions. The purpose of the NEC is to ensure the safety of people and property by providing requirements for electrical wiring, equipment, and systems. The NEC is updated every 3 years to reflect the latest advancements in technology and best practices in the electrical industry. It covers a wide range of topics, including general wiring requirements, grounding and bonding, overcurrent protection, wiring methods, equipment installation, and special occupancies. Compliance with the NEC is essential for all electrical installations to ensure safety and prevent electrical hazards. The NEC provides specific requirements for communications cables, including telephone, data, television, and CCTV cables. These requirements address issues such as cable types, installation methods, separation from power conductors, and grounding. The NEC also includes provisions for raceways, which are enclosed channels designed to hold and protect wires and cables. Raceways can be made of various materials, such as metal, plastic, or fiberglass, and come in different types, including rigid conduit, flexible conduit, and cable trays. The NEC specifies the types of raceways that are permitted for different applications and provides requirements for their installation, including support, grounding, and fire stopping. In the context of communications cables, the NEC permits the installation of multiple types of cables in the same raceway, provided that certain conditions are met. These conditions include the cables being listed for the application, the raceway being of sufficient size, and the bending radius of the cables being maintained. The NEC also addresses the potential for interference between different types of cables and provides guidance on how to minimize this risk. This includes separating power conductors from communications cables, using shielded cables, and grounding the raceway properly. In addition to the NEC, other standards and regulations may apply to the installation of communications cables, depending on the specific application and location. These may include local built-in codes, telecommunications standards, and industry best practices. It is important to consult with qualified professionals and authorities to ensure compliance with all applicable requirements. Proper grounding is a critical aspect of electrical safety and is essential for minimizing the risk of electrical shock and fire. Grounding provides a low impedance path for fault currents to flow back to the source, allowing overcurrent protection devices, such as circuit breakers or fuses, to trip and de-energize the circuit. The NEC specifies detailed requirements for grounding and bonding of electrical systems, including communications systems. These requirements address issues such as grounding electrodes, grounding conductors, bonding jumpers, and equipment grounding. In the context of communications cables, grounding is typically achieved by connecting the cable shield or metallic conduit to the building's grounding system. This helps to prevent the buildup of static electricity and provides a path for fault currents to flow back to the source. Proper grounding is essential for minimizing the risk of electrical interference and ensuring the reliable operation of communications equipment. Electrical interference can degrade the performance of communications cables and equipment, leading to data loss, signal distortion, and other problems. There are several types of electrical interference, including electromagnetic interference or EMI, radio frequency interference or RFI, and common mode noise. EMI is caused by electromagnetic fields generated by nearby electrical equipment such as power lines, motors, and transformers. RFI is caused by radio frequency signals from sources such as radio transmitters, cell phones, and wireless devices. Common mode noise is caused by differences in ground potential between different parts of the system. To minimize electrical interference, it is important to separate communications cables from power conductors, use shielded cables, and ground the system properly. Shielded cables have a metallic layer that surrounds the conductors and helps to block electromagnetic fields. Grounding the system provides a low impedance path for noise currents to flow back to the source, reducing the level of interference. In addition to these measures, it is also important to use high-quality cables and connectors and to follow best practices for cable installation. Cable listing is a process by which a recognized testing laboratory, such as Underwriters Laboratories, certifies that a cable meets certain safety and performance standards. Listed cables have been tested and evaluated to ensure that they are safe to use and will perform as intended. The NEC requires that certain types of cables be listed for specific applications. This requirement helps to ensure that the cables used in electrical installations are of good quality and will not pose a safety hazard. In the context of communications cables, the NEC requires that cables installed in the same raceway be listed for that application. This means that the cables must be certified to be compatible with each other and to meet the safety requirements for combined installation. The listing mark on a cable indicates that it has been tested and certified by a recognized testing laboratory. This mark provides assurance to installers and users that the cable is safe and will perform as intended. Conduit spacers and cable dividers are accessories that can be used to separate different types of cables within a conduit. Conduit spacers are typically used to maintain a consistent spacing between cables, while cable dividers are used to physically separate cables from each other. These accessories can help to minimize interference and prevent the cables from becoming tangled or damaged. Conduit spacers and cable dividers are available in various sizes and materials to accommodate different types of conduits and cables. They are typically easy to install and can be a cost-effective way to improve the performance and reliability of communications systems. In addition to the considerations already mentioned, there are other factors that can affect the performance and reliability of communications cables. These include cable length, cable routing, and termination methods. Cable length can affect signal attenuation, which is the loss of signal strength over distance. Longer cables will experience more attenuation than shorter cables. To minimize signal attenuation, it is important to use high-quality cables and to keep cable lengths as short as possible. Cable routing can also affect signal performance. Cables should be routed away from sources of interference such as power lines and motors. Cables should also be protected from physical damage such as crushing or bending. Termination methods are also important for ensuring good signal performance. Cables should be terminated properly using high-quality connectors and tools. Improper termination can lead to signal loss, noise, and other problems. By paying attention to these factors, it is possible to maximize the performance and reliability of communications cables. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with qualified professionals and authorities before undertaking any electrical work. Adhering to the NEC and other applicable standards is critical for ensuring the safety and reliability of electrical installations. Failing to comply with these requirements can result in serious consequences, including electrical shock, fire, and property damage. It is important to stay up to date on the latest codes and regulations and to follow best practices for electrical safety. By doing so, it is possible to create safe and reliable electrical systems that will serve their intended purpose for many years to come. The continuous evolution of technology requires ongoing education and training to keep pace with the latest advancements. Staying informed about new products, techniques, and regulations is essential for maintaining competence and providing high-quality services. There are many resources available for electrical professionals, including trade associations, training providers, and industry publications. Taking advantage of these resources can help to stay ahead of the curve and to provide the best possible service to clients. The National Electrical Code serves as a foundational document, but it's crucial to remember that local amendments and interpretations can exist. These can vary depending on the specific jurisdiction, so it's always best practice to consult with local authorities having jurisdiction, also known as the AHJ, to ensure full compliance. This proactive approach will prevent potential code violations and ensure that the installation meets all applicable requirements. Understanding the purpose and scope of Article 800 of the NEC is vital when dealing with communication cables. Article 800 specifically addresses communication circuits, including telephone, data, and CCTV systems. It outlines requirements for cable selection, installation methods, grounding, and separation from other electrical systems. Familiarizing yourself with the specific sections within Article 800 will help ensure that communication cable installations are performed safely and in accordance with code. Choosing the correct type of cable for the intended application is paramount for optimal performance and safety. Factors to consider include cable impedance, bandwidth, shielding, and environmental conditions. For example, shielded twisted pair, or SDP, cable is often preferred for data applications in environments with high electromagnetic interference. Coaxial cable is commonly used for CCTV systems due to its high bandwidth and low signal loss. Selecting the appropriate cable type will ensure that the communication system operates reliably and meets the required performance standards. Proper cable management techniques are essential for maintaining a clean, organized, and efficient installation. This includes using cable ties, straps, or trays to support and secure the cables. Avoiding excessive bending or kinking of cables can prevent damage and signal degradation. Labeling cables clearly and accurately will facilitate troubleshooting and future maintenance. Implementing effective cable management practices will enhance the overall appearance and functionality of the installation. When working with data cables, it's crucial to adhere to industry standards for termination and testing. TIA, or EIA 568, is a widely recognized standard that specifies requirements for cabling systems, including connector types, wiring configurations, and testing procedures. Using certified testing equipment to verify cable performance and identify any potential problems is essential. Proper termination and testing will ensure that the data network operates reliably and meets the required performance specifications. In commercial or industrial settings, fire stopping is an essential aspect of cable installation. Fire stopping involves sealing penetrations in walls, floors, and ceilings to prevent the spread of fire and smoke. The NEC requires that fire-stopping materials be listed and labeled for the specific application. Proper fire-stopping techniques will help to contain a fire and protect building occupants. Surge protection devices are designed to protect sensitive electronic equipment from voltage surges caused by lightning, power outages, or other electrical disturbances. Installing surge protection devices on communication circuits can help to prevent damage to equipment and ensure reliable operation. Surge protection devices should be selected based on the voltage and current requirements of the circuit being protected. The NEC provides guidance on the installation and grounding of surge protection devices. Regular inspection and maintenance of communication cable installations are essential for identifying and addressing potential problems. This includes checking for damaged cables, loose connections, and signs of corrosion. Performing routine maintenance, such as cleaning connectors and tightening connections, can help to prevent performance issues and extend the life of the installation. Accurate documentation of the communication cable installation is invaluable for troubleshooting, maintenance, and future upgrades. This includes creating detailed drawings or diagrams that show the cable routing, termination points, and equipment locations. Maintaining a record of cable test results and maintenance activities will also be beneficial. Thorough documentation will save time and effort when diagnosing problems or making changes to the system.